Today I want to show you the current status of my part of the cell simulation. There are 3 milestones: the import of the CT data, to mark areas within the loaded data, and colonize certain areas with cells. For the CT import, I checked which kind of stack data you use. Rebecca provided me an embryo sample in TIFF format. Thanks again for your support. For the simulation, I implemented a TIFF to DICOM converter, because we want to keep the globally presented DICOM standard for CT data in our simulation. By loading the stack data in our simulation, we are able to save the grayscales from the files which we want to use for identifying different kinds of tissues. Before that, we have to reduce the size of this enormous point cloud, which contains over 133 million pixels. First, we segment special values, for example black values or outliers. Then we downsample the pixels by combining all within a certain distance. This leaf size will be the only parameter the user is able to define through the slider. It can be chosen between 1.2 and 2.2. The greater the value, the lesser the total number of pixels will be. After that, I remove the noisy data of the CT by using 2 filter algorithms. Finally, the user can see the generated surface of the data. This is only for visualization, but not for computation. Every simulation step depends on the pixel information underneath the surface. The loading process can take between 10 minutes and 15 minutes, depending on the size of the data and the downsample value you choose. But you just have to load it one time, because we save all processed data in files which we can use again. So you easily can load your mesh and the underlying point data from a saved poly file. In the next step, you can load landmarks from files or create some. Therefore, Rebecca provided me some examples again to see which file format you're using. You can easily transform your PP files to XML and load it into the simulation. By the Show button, you can visualize the location of the markers by the green pins. If you click on Create, you can directly drag a landmark with your mouse. If you want more precision, you also can click on the right or left button beside the coordinate fields and the pencil will move. After that, you can mark areas depending on the created landmarks. If you use the K nearest neighbors with K 2364, you will mark this number of the nearest pixel around the landmark position. In this method, we use the underlying pixel information and you can visualize it before marking. K 1760 will of course be a smaller area. You also can choose all neighbors within a selected radius. Radius of 20 will mark the following area. Now we are displaying the marked area only on the mesh, but its marked pixels are also saved in the memory. Additionally, we mark an area with the 3934 nearest neighbors of landmark LM4. Now we can move to the cell editor. The window on the right bottom of the display isn't finished yet and you can ignore it for now. By clicking on the Polygon button, you can easily mark a required polygonal area. 1, 2, 3, 4, 5 and back to the start pin, and the simulation computes the area. By clicking on the Colonize Marked Areas button, you can spawn cells through predefined settings. Depending on the grayscale, you can spawn different cell types and different colors. You also can drop single cells for experimentations, for example bone marrow cells. By spinning the mouse wheel, you can go through the available different cell types. The wireframe mode is just another pretty mode for visualization of different components within your scene. Finally, our goal will be to approximate cell behavior based on sequences of landmarks. You can upload different states of the embryo and mark the required areas. On this basis, we are able to compute how cells can develop from one state to the next.